Hi, my name is Adewale Adeosun.
Hi, my name is Dishant Khatri.
We are both graduate students at Washington University in St. Louis, and we work at the Laboratory for Advanced Combustion and Energy Research. In our lab, we pursue innovative solutions to energy challenges, particularly with interest on coal combustion and advanced materials. And I am from Nigeria. In Nigeria, we have a lot of energy problems, and I think WashU is the appropriate university to do my graduate studies.
Hi, I come from India, and I'm still which is still a developing country, and getting continuous power supply 24/7 is still a challenge in my country.
And so we think they are coming to WashU, which is the pioneering university on the issue of energy, environment, and chemical engineering, is the best decision for us to make with respect to addressing some of these issues. And so here we are both fortunate to be involved in concept or issues that is addressing specific problems, practical problems. And one of those is the development of the pressurized oxy-combustion, which is able to improve efficiency and also reduce the CO2 emissions that we have as being the major issues with coal combustion.
So, as coal is the most reliable, cheapest and abundant source of energy, but its abundance comes with a lot of challenges. It is also a great emitter of greenhouse gases and particulate matter. So we want to find novel solutions so that the coal can be burned in a much cleaner way.
And so we are looking at things from both practical scale, like a pilot scale, and we're also looking at this from fundamental perspective. I'm going to show you the reactor that we built together to look at how particles are formed during coal combustion. And that's quite important to know because that will help us in developing solutions that will address the production of particulate that are emitted. And so here we have the reactor that could create a well-controlled environment, and particles could be sampled during coal combustion into a state-of-the-art facility which can give us the distribution of these particles as well as their size. And by knowing those two information as well as composition of those particulates, we could develop innovative solutions that could help in avoiding the formation of these particulates.
So the idea behind developing a reactor is we want a local environment and a simple scale setup in which we can imitate the environment which coal particle experience in a coal furnace. So we try to understand these small early stage processes like ignition of coal, like sub-micron particulate formation from coal.
We also use what we call the high-speed video camera technique to look at these particles on a very minute level in terms of scale, and that will give us a visual understanding of how these particles are being transformed. Such understanding with composition analysis will give us ideas on how to come up with solutions that could address this problem, which is very valuable for both my country, Nigeria, as well as Dishant's country, India.